AI models are running out of data to train models. Yes, you heard it right. AI models like Stable Diffusion and ChatGPT are running out of data to train models. So should we be worried about it? The answer is no. First, let me explain you how AI models are created. Let's take an example of Stable Diffusion, which is AI image generation model. Stable Diffusion is trained on Lion dataset, which consists of 6 billion image text pairs, and ChatGPT is trained on 580 gigabytes of text data, which is equivalent to 300 billion words. Similarly, Google's Conversation AI is trained on romance books, so it could be better at conversation. So, what is AI model training? Basically, training is feeding data to AI models so it can learn about it. Like for an example, human babies from birth, we feed them not only food, but also data like languages, and eventually the babies are able to speak that language. Similarly, AI models are fed with data to create an idea about a topic. This is simplest way to understand AI model training, which is really complicated process. This is traditional method of making AI models. If AI model is car, then data is fuel for it. Now, you're thinking why there is need to worry about it, because so much data is getting created on everyday basis that we will never run out of it. But there is a catch. Not every data can be used to train of models. There is need of well-labeled high-quality data to train models. Most of data on internet is spam and have bad quality, so distinguishing and labeling this data is so much time and money consuming. Because suppose AI is trained on news available online, most of this news could be rumored or fake, so it will give us fake and rumored info. Therefore, it is important to train models on high-quality data, and we are running out of this high-quality data, and according to researchers, we will run out of text data by 2030 and image data by 2060 because creation of data can't keep up with speed of training. And why we should not worry about it? There are some reasons, because the situation is not bad as it seems. There are many unknowns about how AI models will be developed in future. Will it depend on data training or new technologies will be developed? No one knows. I am sure there will be more powerful algorithms to use already available data more efficiently. There will be more powerful hardware which will use the data efficiently. There is one more promising solution: synthetic data. Now, what is synthetic data? Using synthetic data methods, companies can acquire training data far more quickly and cheaply than the alternative, laboriously collecting that data from the real world. Imagine how much easier it is to artificially generate 100,000 images of, say, smartphones on an assembly line than it is to collect those images in the real world one by one. And importantly, real-world image data must be labeled by hand before it can be used to train AI models, an expensive, time-consuming, error-prone process. A key advantage of synthetic data is that no manual data labeling is needed. Because the images are digitally tailor-made from scratch in the first place, they automatically come with pixel-perfect labels. How exactly does synthetic data for computer vision work? How is it possible to artificially generate such high-fidelity photorealistic image data? A key AI technology at the heart of synthetic data is known as generative adversarial networks, or GANs. GANs were invented by AI pioneer Ian Goodfellow in 2014 and have been an active area of research and innovation since then. Goodfellow's core conceptual breakthrough was to architect GANs with two separate neural networks and then pit them against one another. Starting with a given dataset, say a collection of photos of human faces, the first neural network, called the generator, begins generating new images that, in terms of pixels, are mathematically similar to the existing images. Meanwhile, the second neural network, the discriminator, is fed photos without being told whether they are from the original dataset or from the generator's output. Its task is to identify which photos have been synthetically generated. As the two networks iteratively work against one another, the generator trying to fool the discriminator trying to suss out the generator's creations, they hone one another's capabilities. Eventually, the discriminator's classification success rate falls to 50%, no better than random guessing, meaning that the synthetically generated photos have become indistinguishable from the originals. In 2016, AI great Yann LeCun called GANs the most interesting idea in the last 10 years in machine learning.
There are many other ways to overcome this issue, like developers are increasingly exploring content beyond the confines of freely available online resources, including those owned by major publishers and offline repositories. Consider the vast number of texts published prior to the advent of the Internet. If digitized, they could serve as a fresh data source for AI initiatives. One of the globe's most extensive news content proprietors, with a significant portion of its content behind a paywall, recently announced its negotiations with AI developers regarding content agreements. Such arrangements would necessitate AI firms to pay for training data, a departure from their usual practice of freely scraping it from the Internet. Content creators have voiced their opposition to the unauthorized utilization of their content for training AI models, with some even filing lawsuits against companies like Microsoft, OpenAI, and Stability AI. Receiving compensation for their work could potentially rectify some of the existing power disparity between creatives and AI corporations. In conclusion, we should focus on developing more immersive hardware, develop more technologies, reduce dependency on free data. That's all for today. Thanks for watching. Don't forget to like, subscribe, and press that share button to make Algorithm Bro happy.